In this lesson, we're going to be looking at equivalent fractions, and to be more specific, we're going to be looking at how we find the missing values in an equivalent fraction. Now, if you notice here, we have 1 over 4, a quarter, and that is equal to an question sign over 12, and a question sign in math means the unknown. Okay, so basically you could replace this question sign with x because it's a missing number, missing value that we're searching for. Now, as I've stated in previous lessons, that when working with equivalent fractions, you must always look at the simplest fraction, okay, and then you can work your way from there to find the other fraction that has some part in it missing. Now, 1 over 4, this is saying that I have one part shaded out of a total of 4 parts. Okay, so again, before I calculate this mechanically or just go ahead straight forward and calculate it, I prefer to show you the concept behind this. Okay guys, so this basically is saying that I have a total of one part shaded out of 4, so I can represent this on a diagram. So I'm going to shade my one part out of 4. So this is one part that I'm shading. Okay, so now I have one part shaded out of a total of 4 parts. So there are 1, 2, 3, 4 parts in the whole. Now I need to find how many parts inside this whole that is equivalent to a quarter that has a denominator of 12. Okay, so the amount of parts that are shaded is missing. Now what I'm asking myself is that if this whole has 12 parts in it, it simply means then that I must divide the whole that I have here in 12 equal parts. Okay, so if I have 4 parts, it simply means then I would have to divide each part in this whole, I would have to divide it into 3 equal parts. Okay, so let's go ahead now, and I'm going to divide this into 3 equal parts. So that's one part and that's another. Okay, so here, let me just make this a little bit bigger. Let me put it at 4. So here, this part here is divided now into 3 equal parts. So now that suggests that I would have to divide this part also into 3 equal parts. So I'm going to divide this part into 3 equal parts. And again, I would have to do the same thing here. Divide these parts into 3 equal parts. So let me do that quickly. Now, if you notice what's happening here is that I have a total of 1, let me change my marker, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a total of 12 parts now inside my hole. Okay, and if you notice what has happened, I haven't the size of the hole hasn't changed. Oops, sorry about that. The size of the hole hasn't changed. Okay, it's just that I have divided my hole into smaller parts. Okay, so basically what I'm asking myself now is how many parts out of 12 parts that are shaded, and I would say there are 1, 2, 3 parts that are shaded. So therefore I can make my statement to say then that a quarter, 1 over 4, is equal to how many parts I've shaded? 1, 2, 3. A total of 3 out of 12 parts. Okay, and that's my answer. Okay, so my missing value here would be 3. Now let's quickly look at another example. Now in this example, the denominator is missing. In the previous example, we found the numerator, so we're looking at the fact that when we have a missing denominator, it's really the same concept now, guys. All I'm saying here is that I have a third, and as I've always stated, we should always look at the simplest fraction. Here I have a third, 1 over 3. So basically what I'm going to be doing, I'm going to shade 1 out of 3 parts inside my hole, out of my hole. Okay, so let me get this quickly. So I'm gonna shade this quickly. So let me shade this part. This is one part that I'm shading out of my entire whole. Okay, so there I've shaded one part out of my whole. Now my whole 1/3, this has 3 equal parts. Now what this is saying basically is that I know that I've shaded. Since my numerator tells me how much parts I'm dealing with in the whole, I would have known that I would have shaded 2 parts out of this whole, but I don't know how many parts there are in the whole. So by intuition, what I'm going to do is that the part that I've shaded, I know that it would these 2 parts here would relate to this one part here in the numerator. So all I have to do now is to divide my one part that I've shaded into 2 parts. Okay, so I'm just going to divide this into 2 parts. So there we go. So I've divided that part into 2 parts. Now if I've divided this part into 2 parts, the shaded region, then I must do the same for the other parts. So I'm going to divide these parts into equal parts, 2 equal parts, and then I'm going to divide another part into 2 equal parts. Okay, so here now basically what is happening when you look at it, I would have a total of 1, 2, 3, 4, 5, 6 parts inside this hole, and if you note carefully, I would have 2 parts shaded. So basically it's that easy, guys. So now I can state therefore that a third, 1/3, is equal to 2/6. And if you review our playlist on simplifying fractions, you would have realized that if you simplify 2/6, it is the same as a third, because 2 into itself once and 2 into 6 goes 3 times. Also with a quarter and 3/12, if you simplify them, you'd get the same value. So that's the whole concept behind equivalent fractions, and as I said, I like to use diagrams. It tends to bring out the concept a little bit clearer. If you have any questions, feel free to post them and we'll get back to you as soon as possible. Bye bye.